Hello, everybody. So, continuing the example from last Thursday, I believe, is that's pretty much it for tonight. It'll probably be a short night. There's some tips I want to go over on making the queries, continuing that example. We quickly looked at the example I prepared ahead of time. That was the finished version. And one of the things y'all have seen a few times I like to do in classes, go over how we get to that. Because typing SQL code with Java, especially when we want to automate the process eventually, can get a little complicated. So mostly it's going to be talking about a couple tips on that while we build the big complicated insert queries, and then look at a couple others, maybe to select and delete, but they kind of all run the same way. So a lot of just tips and roundabout ways to make it easier to get some of those things developed. Before we get started in that, a quick announcement. I got an email the other day that on this Thursday, November 3rd, there's going to be the active shooter drills on campus, and the evening one is right at 6 o'clock. So right at the time our class starts. So probably a good day to be a few minutes early, coming to campus 15 minutes early or 15 minutes late, and avoid that. And on the Zoom call, the first 10 or 15 minutes of class at 6 o'clock, we won't be able to really do a whole lot. So on Thursday, go ahead and expect we'll be starting about 15 minutes late. I guess I'll go ahead and say that. Because can't really do much during the when there's an active shooter drill going on. I have to just close the door and wait for him to say it's okay to get started again. They usually only take 5 or 6 minutes, but after your 15 minutes will give us plenty of time. So let's just plan on starting about quarter after there. So if you want to drive to campus, you might want to be a few minutes, make sure you're a few minutes before 6 o'clock so you don't get stuck in the hallway, or just show up a few minutes late to usually those only take a few minutes, and so hopefully by 6:15 it'll be back on schedule. I always think that's a terrible time to do stuff, because that's right when classes start back again. And yeah, 6:30 would be much better, because then it's not in that commuting time. Things happen, people might be a few minutes late and end up stuck in the halls, or arrive at a time when they're not aware of that. But for us, yeah, we'll just I'll be here like normal, and it just be kind of a very slow start. So anticipate that we won't really get into anything till about 6:15 or so. And if I'll wait till you get that.
Was that me?
Yes.
Nope.
There you go. Oh no. You might have to actually turn it off. Oh no, I got it. I lost my train of thought. So yeah, I'll be here and just kind of going slowly, getting started. And if you come on the Zoom call and it seems like the class hasn't started yet, that probably means the drill is running a little bit longer than I anticipated. Because I don't know for certain how long those things take, but the last couple only took 5 or 6 minutes. So hopefully it'll be like that. Okay, so now to our stuff. It's going to be kind of a short night this evening, finish the next steps in that example. But it's almost everybody's project involves some sort of data stuff. Y'all all turned in ideas that would require some sort of database. So as we look at this, just to recap, last Thursday we talked about setting up databases, or just a quick overview on databases and then set up a small one for our class example. And then got ready to do the code, but the last couple of classes had run long, so I decided that we could wait till this evening to actually go over building that code. So that software, as a reminder, that software that I asked you to install for the class champ, a virtual server to run locally and test things before posting them on the internet, make sure everything's ready, good to go. Virtual machines are very useful for that. And you might need to restart MySQL, and I usually go ahead and start Apache with it as well. Go ahead and start both of those so that the database is up and running. And then last week we built a small database to get to. So once the champ is running, if you go to localhost and then slash php myadmin, we'll get you right to the php myadmin software. You may need to sign in. If you haven't changed your username and password, the default on MySQL is root, and then the password is an empty string. So you just need the opening and closing quotation marks for that. So this is a fairly popular application for working with MySQL databases, but it's a GUI that has all of the controls of MySQL database, and there's a lot of functionality there. So the GUIs that control those are always a little overwhelming. There's a lot of buttons on there, and they're dynamic. The buttons change depending on what you're doing. Really get into that is the database side. Mostly what we need to do, if anything, is just create a database to connect to. We can do that from our Java application, but normally the database is created separate and our software is just going to access it. So that's kind of what we did here last week. We just kind of set up a new database to work with. I think it was this one. Yeah, and just put one table in there. I inserted a couple rows. I guess we don't really need these. Let me go ahead and delete these. But standard classroom example data that I like to use: name, age, and town. In real situations, obviously, database is going to be much, much larger, but when you're tight time constraints, we can see the basic concepts here. And so the points I wanted to talk about. So I'm going to empty that out and just leave this open because we will need to see what's happening in the database in order to do some of the testing and debugging and getting everything together. So then back over to Java. I'll open up NetBeans, and whatever IDE or text editor or whatever you're using to develop your code, it's going to follow the same process. The difference is just where the buttons are located. And the people that made the IDE might have probably used a different style sheet, but the same functionality is required in order to be a Java development environment. So here's the one we started last week. We created the new project and basically just generated the main file and got rid of all those comments that I should really go into the template and get rid of, because I just delete them every time, so they obviously don't need to be there. And got it ready to do our main application. So there's a couple things that we will want to work with. And one, in our database, the table, we talked about databases last week. Every field or cell in that table holds a single data point. So the fields are connected into records, which in the table form is a row. So each row in the table actually represents a single item. If we look at the ID, person ID number 1, and then all the data we have about that person fills in that row. And similar thing, if there's multiple tables in a more realistic situation where we have lots of tables scattered everywhere, we'll have one, each individual row would represent a particular person in our case. But whatever our data is, in the online retail store, each row would represent a particular product, maybe, or a particular customer. And everything in a row is connected. So the most logical way to approach that from the software side is we develop software to process this data that we have stored in this database so that we can do more than just print it out and see what it is. We want to react to this data. So we set up our software ahead of time so that whenever the company is ready or whenever somebody's ready, they can ultimately with a GUI click some buttons and get a reaction from the software about what's in that database. So representing it as equivalent to the row here would make the most sense in our text file. And it looks very, very different in a SQL text file and a Java text-based script before we compile it or anything. But remember what we see, what we see is very, very different from what the CPU grows. And it is not a coincidence that the term we use in object-oriented programming for each individual data point, a data field, is the same in a relational database. And most of our non-relational databases also have data fields there, and our object-oriented programming. It looks very different in the text file, so we don't need to dive into that too much because we work in the text files. But there's, when you compare them in binary, when you compare them even assembly language, there are a lot more similarities than it seems like looking at them in the two different text file versions of them. So that's the first thing I'm gonna do. I like to do is make a Java class to represent each row in the database or each record. I'll go ahead and use that name. It's a nice, useful name. And if you had a particular table, a bunch of tables, you might want to extend that name to include the table and record, or some sort of naming scheme so you can tell what each thing goes with. And keep the same, or try to set up the same organization in your application as you have in your database. That way, what's in storage and what's in RAM somewhat mimic each other. So each record, we can look back over here, has an ID, which is an integer. Auto-incrementing, the database is handling that. Then a name, which would be a string. Age, we usually get that in integers. Babies are an exception, but those are usually given in integer month, weeks, and then integer months until it gets up to 1 year. So we don't give ages and floating point numbers still. We change the units for babies. And name and town would be strings. So we need to match that over here. And if you have lots of tables, it can be a good idea to set up different objects to match your different table. So you have that nice little spot to put the data after you grab it from storage. So, whoops. So we'll have a private integer for ID. And I'm just going to go ahead and use the same name I did over there, the same capitalization and everything. Organization goes a long way. So we'll just create that, but we're not going to have anything to put in that field until we grab something from the database. So definitely don't need any initializations. A private string for the name of the person, a private integer for the age of the person. And I'm going to break with Java convention and go ahead and use give those the same names they had in the database to avoid any confusion. What's what? Just there is that Java convention, but I use Pascal case over in, actually not even Pascal case. I changed up the notation over in the database, so I want to match that so that to minimize the confusion. A little bit of organization goes a long way. So it's good to think ahead on that stuff as much as possible. And then the town, the person that's in. And then otherwise, this is just a place to hold our data. The database is over in storage, long-term storage. That's on the SSD drive or the disk drive or whatever our long-term storage is. And the software is running in RAM. So this is just a mimic of the database, of each database row in a format to go on RAM and registers. So all we need is constructors and getters and setters. So all of that can be generated, and like always. So if we push Alt Insert or wherever the automatic insert code insertion is for your particular IDE, constructors, getters, and setters always have that same base format. Sometimes we'll come back and edit the constructor for things that we want to happen that aren't automatically generated, but they always have that same basic format. And getters and setters are always exactly the same. So any place we type Java code can handle that stuff. And I'm going to set up a couple constructors right off the bat, just an empty constructor so we can start and then use the getters and setters to fill it up. And then I want Alt Insert. I'll do a full constructor, select all, and then one more that only has 3 fields because of this field right here. That ID was auto incremented in our database, which means the computer's handling that. So the only thing we ever want to do with that is read what it is. Technically, we do have write access to it, but it would probably be a bad idea to go in there and start messing around with that. Just let the computer handle it. So this first constructor that includes the ID is for when we get stuff from the database, because we'll have the ID. But we also need one for when we're going to send stuff to the database that we can leave the ID off of and let the database insert that after we send stuff. So insert another constructor with everything except that person ID, except the ID. Or you can type all that stuff if you really like to, but humans make typos, machines don't. And any place you have to write Java code should have, at the very least, a plugin that you can put in to generate all those getters and setters. Or it's not hard to write a little script that does that, because it's just a text file. So all you need to do is write that stuff to a text file. It's always the same, at least for the base starting point. It's not a complicated thing to write. So there's lots of them out there. Then the getters and setters, and once again, I'll just set them for all of them. I'll just do all of them. But we really don't want to accidentally change that ID. That could cause a problem. So I'm going to delete. What I usually do personally is I generate all of them and then delete the ones I don't want. So like the set ID. Don't want to accidentally change that. The getter probably still want that. Might need to see what that is sometimes. Or we might need to use that in another query. On a big database, probably not in our simple example here. But if we had lots of tables, we might need to grab the IDs from one table and use those in the subsequent query. Probably, that's the sort of thing you should have seen in the SDEV 110 class, but it's just so loaded down with information that class should probably be split up into 2 classes. Keep adding things to it. And in a lot of ways, it seems like they're not adding the right things to it. They keep adding more and more to it, but it's like high level data analytics stuff. That could wait till later classes and they give an introduction to other stuff there. And I guess we might as well do a two-string thing so we can print stuff. I'm just going to do alt insert, and on NetBeans, we can also use the string builder that will just automatically give us some sort of string. Not a super nice one, but it'll print out our data so we can see what it is. And on Thursday's example, we'll improve the two-string method here. Because after we look at the queries today, on Thursday, we'll tie it into an interface where with an HTML form, we use a JSP page where we can click on stuff, click on some buttons on a web page, and then grab the data from the database or type into a text field and add a new record to the database. A really simple interaction that way. Because there is one thing with databases we have to worry about. That's all we need for that object. I was just kind of pausing in case y'all wanted to type a different two-string or something. Talk about this here. The one thing we really have to worry about is something called SQL injection. Since big databases are usually held on servers, not on local machines, and lots of clients are going to need to access that same server, we do that through the across the internet, which means query requests are going to be passed as URL strings, either with a get method where it's actually text that we can see, or as a post method where we can't see the text, but we can't see the text if it's generated. But if we tried to manually type it, that would get processed somewhere along the way, and it would stop showing to anybody else that looked at it. So we can still type it, even if other people can't see it after we type it with a post. And if there's ability to pass an entire query in at once, basically anybody with the internet access could pass queries back and forth to your database from the website that actually has automated access to the database. And the thing with SQL query injections, the big thing is that's the one that the programmer has to deal with. Most everything else in cybersecurity, it's a cybersecurity person that deals with that. But the only way to stop a SQL injection happens when you build the program. So that's really the big one the programmers have to deal with. We hear about secure coding all the time, but SQL injection is the only one that only the programmer can stop that when they build the program the first time. So it's security is very, very important to that. So all generated code, so you see that's that object is building the class is very easy. Just think ahead a little about the data fields you're going to need. And if the database is already there and ready, then you don't even have to think about that. You just have to type them once and then generate the rest of the code from whatever IDE you're using. So that gives us a place to put our records when they come back. And here's the one with our main method. And a general rule of thumb is you don't want to define your classes in the same spot you use them. The main method is just one setting where we can run this. So the file that has the main method should really only have the main method in it. And everything else happens elsewhere. That way, if we want to change the settings, like we're going to do on Thursday, and instead of running the main method like we're doing tonight, syntax example, we're just going to move everything over to JSP. Then all we have to change, all of our other objects will still be exactly the same. The only thing that's going to change is where we initially started from. We're going to start it from a website instead of from the main method. So minimize what you put in you want to minimize what you put in the main class And you don't want to include a main class in all of your other classes. I've seen that a couple times this semester and every time I've taught Java. So like here, if we went ahead and put a main method here to test this, just to see if stuff was working, there's not really anything to test here. It was all generated code, and people at Apache tested that way before we hit our generate button. But if we built our class and wanted to test it and do a main method in here, we could never use that class anywhere else because there can only be one main method. So having two of them would throw things off, and the Java virtual machine would get confused on which one to use, and we could never create an instance of that class without also having that main method included. Hopefully that makes sense. So only one main method. That's the rule. We have to just have to watch out to make sure we don't make an extra main method. That will confuse the computer because that is a specific name. It won't fail to compile if we put multiple main methods in there, which makes it even more of a problem because then it'll compile and we'll think everything's fine and hit run, and then the machine will get all kinds of confused trying to run multiple main methods at once. So minimize what you put there because the setting can change. You suddenly decide you want to switch over to a website. All you have to change is that initialization thing. Put all of your logic over into other objects or other classes. So now that we have a place to put each record, we want to go ahead and actually connect to our database. So I'm making a class for that. Once again, a new Java class, and MySQL connection. The thing I called the main method would probably be a better name for the actual connection to the database. I'll call it database connector. That name I put on the project would have been much better. Now, I'm still saying this a couple times. Remember, in Java, the name of the class has to match the name of the file. We can't mix and match those because when we compile it, it becomes an independent compiled object. And then when it gets hashed and put into, for actually working with the CPU, we'll talk about hash tables later this semester. When it gets hashed, it pulls from the file name to do the hashing, which means if we give it a different name than the class name, what the CPU knows our object as is different than what we know our object as. So in C++, we were free to call things whatever we wanted, and that caused a lot of problems and some confusion and extra difficulties when debugging it. So that was one of the restrictions when they created Java, and then C# followed suit. The file name and the class name have to match, and then that way, after it gets hashed and put into a hash table for the CPU to actually process and work with, the CPU knows our objects by the same name as we know them by. And we don't get lost trying to track down problems. But even short of the long explanation on it, it is a restriction in Java. We have to, the name of the class has to match the name of the file. And it's not an arbitrary decision. It makes a big difference. Whenever that issue shows up, it can be incredibly frustrating to deal with. After you debug something once with that issue, you never want to name your file and class anything different again, no matter what language you're in. So yeah, I hope I never want to see that again. It is a hard thing to dig through when the hashing gets off. Okay, so what do we need for this? This is actually our connection to the database. So there are really three things we need in order to connect to a database. Where is that database located? So a uniform resource locator. we need some sort of username and a password. So where is it located? And who are we that we have access to? How do we access it? So I'll just set up some data fields for those, and then we'll pass things in to this object whenever we get it, because we want to generalize our class as much as possible, right? If we're doing a MySQL example here, but maybe you suddenly decided you wanted to switch to Postgre. Everyone wants to decide the company wants to upgrade to Postgre from MySQL. You don't want to have to rewrite everything from scratch. But if it's just completely generic SQL thing, work with any structured query language. Only structured query language here, so the particulars like the actual URL and the password and stuff we can pass in later so that we can change to a different database. Or that would be another thing, backups. This database is important, so there's probably more than one of them. So our objects can automatically be duplicated to go to the primary one and then a backup. And depending on the company and the data being stored, there might be several backups. So it's definitely things we want to pass in. But URLs are handled as a string, as you all probably know from typing in lots of website addresses over the years. Those are just Unicode is what transfers across the internet. So if it's going across the internet, it's probably a string. Is a good rule of thumb. Usernames and passwords. So that's where it's at. And how do we access it is username and password. So kind of the same thing, private string username and private string password. And now we're going to generate some structured stuff. But first off, I want to point something over in the database. Username and password, I haven't changed the default for the class example. It's still root and the empty string for the password. It's a very, very bad idea to do that. You want to grant specific privileges, and that includes your software. So when software is going to be accessing the database, you don't want to access it. You don't want the software to access with one of the human user accounts. Your software is a separate user itself and treat it that way. Give it its own username and password. Over in MySQL, it's there's a table on here that does it. Where is it? MySQL table? Yeah, we go to the MySQL database. There's a table down here called user. And here's all of our users and the passwords they have access to. I'll go ahead and make a new one. Just I'm going to skip all that. That's SQL stuff. Y'all would have seen that. Create user, grant privilege. Yeah, well, might as well. We need to create a new user. What did it do? But whatever it is, it's not what I meant to do. I'm going to create a user. And it needs two things. It needs to know the username and how they are going to be accessing. So how is that user going to be accessing the particular database? So I'll say Java at localhost. So coming in on the localhost server, there should be something called, should be a user, Java at localhost user. So that added a new user to our table. But right now, you'll notice under select privileges that Java user does not have select privilege. have insert privileges. And really, it doesn't have any privileges. So I'm not going to use this one. I just wanted to go over this. Something you would see in your SQL class. But right now, that user doesn't have access to do anything. And you want to minimize it, right? So for our example, to keep it easy, I was just going to use the root there at localhost. Oh, which I created that wrong. Let me delete that and create that correctly. The @ symbol is not part of the string. Create user Java end of that string, then @ and a new string for localhost. Sorry, I kind of dropped the ball on that one. Username and the local host, or if it's a separate IP address they will be coming from. So we can restrict it, right? If you know they're always coming from address, I don't know, 123.45.22.159 or 129. If you know it's always coming from that particular IP address, you just put that IP address on and add some other layer of security because nobody else can access the database. The software is going to include a password on it. So if somebody else gets that software and tries to use it to get into your database, they can only get there from that one particular machine. Usually a good idea. So set that up and then run that. Now if I go back to the user table, there we go. Now we can actually see it. So a user called Java will be coming in on from the localhost server, which means it will be running on the same machine. And right now it doesn't have any privileges at all. So we can add those. So like grant privileges, and then list out the ones you want it to have. So like select, insert, update, delete. That's probably what you're going to give. That's probably the access you're usually going to give. You can give it all sorts of accesses or just the asterisks. Give it all privileges. Grant privileges, these to Java at localhost. Might be another thing. I'm used to doing this in the console where I'm not actually using a database yet. So maybe I need to do this. SDEV 200 database. That might need to go in there. I'm used to typing it someplace else, but basically it looks like that. We're not going to use it very fast tonight. Make sure you do that in a real situation because you want to make your software its own user database, or tell the database administrator what privileges your software needs, and then they will send your password. Probably a big long 64 character thing. You have to copy and paste. It's almost impossible to read, and then gets salted and encrypted afterwards still. But they'll send you a nice secure password to use with that username. I think that's right. Oh, something went wrong. You have an error in your SQL syntax. Right, syntax user select, insert, update, delete. Let's put everything on there. Grant privileges, everything. Nope. I might have to look that back up. grant privileges MySQL. Oh, wrong order. Go back. Privileges goes over here. Or you can just type the word all or the wildcard. Did I spell privileges wrong? Oh, I can't do that from here. I have to come up to the top level where you're not actually using the database. This is what I normally do. That's what I was a little worried about. So grant these privileges on SDEV 200 database dot people table to that. Am I remembering it correctly now? There we go. So grant, list out all the privileges. That one is something that happens rarely. That's probably what we want our software to do. So while it's on the screen, maybe take a screenshot of that, because that is a hard one to remember. And if you start digging it up, you're going to see huge, complicated data analytics things. So that sort of query right there. And then the one before is really easy. So create user and then that username. And then run that and any whatever other particular privilege you need. But usually software is going to put stuff in the database, pull stuff out of the database, change stuff in the database, or delete one record at a time from the database. And if you do it that way, you can restrict it to which tables it can get to and everything. Because remember, software is not intelligent. You don't want to let your non-intelligent software run freely in your database. That could cause issues. But again, that was just going over those things. You probably want to put all that stuff in there. And yeah, if you go searching for it, you'll get to things like this, like Turkio, which is very complicated in their data analytics tutorials. Database administration, when you go look stuff up, there does not seem to be beginning tutorials. If anybody's ever encountered that before. When you go look stuff up, it looks like the tutorial that Google puts at the top is for somebody that's been doing database administration work for 20 years. 20 years or 40 hours a week. And the tutorials seem to be made for them. That's what I was saying, take a screenshot of that, because that's probably what we want, or a slight modification. Like maybe you do not want your software to be able to delete the database. If anything, your software sends an email to the database administrator asking them to delete something, and the software can't automatically remove anything from the database. All it can do is add stuff to it and choose what's there. So try to minimize what the software is able to do, because software is not intelligent. If it makes a mistake, it will go ahead and make it over and over and over again, and that can cause big problems in the database. Very quickly, like in milliseconds, it could make a big difference to millions and millions and millions of records in the database. So you want to be cautious about those things. Whoops. And now I guess I'll start with the constructors. So I'll generate an empty one and a full one. And on this one, that's probably enough. And really, we'll probably use the full one every time, because we'll know what database we're connected to, no matter where we connect to it from. And as for the getters and setters here, I usually don't put getters and setters on these, because, well, one of them is a password. We don't want access to that password, right? So any place that password is going to be hard coded in. For one, don't hard code it into your file until you're ready to compile. Usually we type that in. The standard is kind of, you leave that blank or have a temporary incorrect thing placeholder there. And then right before you build your software, you type in that password, compile it, build it so it's no longer in human readable form, and then delete that password from the text file immediately. That's just, hopefully strikes you all as just basic security measure, right? Don't just leave the password hanging out in the text file where anybody can see it. And likewise, even once it's compiled, if you put a getter on it, somebody could instantiate this object and then use that getter to grab the password from the database. So basic security measures, secure coding, nothing really fancy there, and you don't have to take very many steps, but because of SQL injection, anytime you're working with a database, you want to watch that, because that is the one thing that only the programmer can block. And it's really easy to block, but it's actually, I'll at least one of our methods tonight will build a SQL injection and show you how easy it is to make it. I can say it right now, a real easy thing to do. We know we're going to have to put a parameter there, so why don't we just, or we have to build a query, so why don't we just make a parameter, and that way we can go to a nice text editor and send the whole SQL query in at once. And then that's what causes SQL injection. So basically all we have to do is anything that avoids that. The standard is to parameterize it. So instead of a parameter that takes in a whole query, your methods that can actually access the database only take in parameters for particular fields or values. That way, somebody cannot pass an entire query in through your software and manipulate your database. So now we are ready to connect to the database and start doing some stuff. So that was coming on 50 minutes, and 50 minutes was what I was thinking would be a good midpoint for a break. Was it last night's class? Yeah, last night's class. Took a break at 7:15 without thinking, just out of habit. The plan only had us going until about 7:45. So it was a very uneven mix of before the break versus after the break. So I've got to start focusing on that a little bit more. So about 50 minutes is my estimate of halfway through what we're going to cover tonight. So a little earlier than, we won't go all the way to 8:50, obviously. And we're at a good stopping point, because now we're ready to build our methods to actually insert the query. Does anybody have any questions about those first steps? Yeah, just the basic textbook example of classes and first steps of secure coding. Remember things like we don't need a getter for our password. Obviously, just saying that sentence makes it automatically sounds like a bad idea. So that's sort of the most fundamental secure coding ideas. Otherwise, it's a straightforward set of classes with getters and setters up until we actually make the connection to the database, which we will do right after the break. And then we'll do it a couple times because they're all almost identical. The tricky part is building the queries in our code, because the one thing we do not want to do is just set a parameter where we pass an entire query in, because then anybody that has an internet browser could use that parameter to pass an entire query in and do whatever they want to our database. So to avoid a SQL injection, it's just don't put a parameter like that. But only the programmer can leave that off, basically, is the idea. 10 minutes sound good to everybody? I see head nods here in the class. So my clock says 6:49. We'll get back to it at 6:59. See y'all in just a moment. That worked out really well for like nice stopping point at the time I was looking for. Stop the recording.